Okay, well, thanks very much for joining me today. And thanks for the opportunity, Andy, as well, for inviting me to talk CTO Craft. Quite a last minute talk, I'm sure, plus of the mile, so I won't make any more excuses and get on with it. So yeah, little bit about me. I'm an independent software consultant. I've been a software developer, lead, build and config guy, PO, head of engineering, and lots of different things over 25 years in banking, telecoms, insurance, and lots of other different industries. And this year I've kind of gone out as a kind of independent consultant for the first time, and I've been thinking quite hard about subjects that really interest me. And this is something which I was looking forward to presenting maybe a bit later on than this, but this has actually given me an opportunity to kind of bring some of my ideas together. So bear with me. I'm particularly interested in systems thinking, Conway's Law, reverse Conway maneuver, that kind of stuff. Team Topologies, which is an excellent book, which I'll come back to later. And also really the kind of whole movement around the team is software kind of approach that we see around quite a lot these days. So a little disclaimer, like I said, this talk didn't exist this time yesterday, so it's a bit last minute. Pictures are raw and a work in progress. I hope to improve them and maybe change some of the examples that we got. Blah, blah, blah. Please provide some feedback. Thank you. So I'm just going to talk today about legacy and legacy code, legacy systems, and what actually is. Maybe it's good to start to define it to begin with. And when you see legacy, or you do a search for legacy or try to understand legacy, you also see it kind of conflated or confused with technical debt. And in fact, they're probably talked about in the same terms a lot of the time. And that's what I want to explore today, really, on this basis. It's like we talk about technical debt all the time, but what is that? If you look at Wiki, there's a great page on it, which I just discovered today, which has 15 categories of technical debts. And those are quite broad buckets as well. I'm sure this page changes quite regularly as well. And I think it's fair to say it's a subject for debate. For me, everything is potentially technical debts. I think for a lot of people as well, you can make decisions. Every decision that you make essentially means that you get on a path, which may mean that something in the future is limited. So for the purposes of this presentation, I'm equating technical debt and legacy as being the same thing, and also looking at how our systems kind of encroach into our applications and how that becomes a part of our thinking around how we deal with legacy. So when does software become legacy? And of course, when we start to build some software, we're always building from an assumption. We're building from an idea, maybe it's a requirement or a user story or something like that. But immediately, as soon as the code hits the editor, it becomes into a form which may or may not completely capture what the original intention was for the user. And then when we get to a point where we can actually deploy that application, we can get some feedback, and we can immediately get some feedback from a user. Maybe it works or it doesn't work in the way we want to it, and we can make a change which will enable us to improve that situation or add a new feature. But of course, as we deploy stuff, it then also becomes more difficult to make changes because we have other systems that we use to get there. And by the time we've got to a deployment situation, other parties get interested around what that actually means and how, for example, we'll see in a second, that will affect our future application, the architecture. Feedback can mean that we, for example, will add whole new pieces that we've completely forgotten around, I don't know, user access, for example. Perhaps compliance and security become more important aspects that we didn't previously consider too closely in our initial design. So I'm going to look at an example with the Amplify framework. I don't know if you're familiar with this, but it's AWS's framework to enable you to quite easily scaffold a new application, including the infrastructure as well. So it's quite a nice way to envision not just a front-end application, but also a back-end, maybe middleware, etc., APIs. So we've got this example here where, and this, excuse this graphic, it's pretty rough. I just drew it on a board over there last week. It was never intended for public consumption. Anyway, you'll see on the left-hand side, there's a developer duck, as I've called him, or she, and she is writing some code and putting it into Git. She's maybe created an Amplify app, for example. She's used the Amplify CLI, scaffolded it so to create a React Native app, with a GraphQL API, with an S3 bucket, maybe some lambdas, etc. And that's nice, and it's been scaffolded, it's been created, and then she can go and create some features. And she has a feedback loop. I'm not sure if you can see my pointer, but she has a feedback loop that's quite quick, either around a CI or with a local development environment. And eventually she will push this to AWS, and it will get deployed using CloudFormation to create the endpoints that the user can log onto. That's fine. So at that point, the developer has created something and it's been pushed to AWS, and then we deploy it and we see that other people get interested. So we have other ducks. We have an ops duck, we have a security duck in this case, who are in our organization still, but they're very interested in how they can help the user understand and better support the user, in the deployed application. And they themselves will have requirements as well, which will feed back into our development cycle or into our application cycle. So essentially what we're seeing is that when we get to a point where we've deployed an application, even a simple one, we have basically legacy built in already. We have something which we have to deal with from a user perspective. And this affects it causes load. It causes cognitive load. If you're not familiar with this term, there are some great texts around it or using it, and Team Topologies is one of the current books which mentions it quite a lot in terms of how a team shouldn't be overloaded in terms of what it can cope with on a day-to-day basis. Once we have an application in production, it is essentially a legacy application at that point because of this load, because of the other services that we put on top of it to make it acceptable for a user to be able to provide the feedback to. And how does this manifest itself? Well, there's another good quote here from a book which I'm reading currently, which is around technical debt. And that is what you feel when the next time you want to make a change to that application. So the developer has a feeling that this is going to be difficult because X and Y. Maybe going back to our Amplify example, it's a little bit simpler in the short term because Amplify does scaffold this all up for you. It creates CloudFormation for you. So perhaps you have to make some changes in a declarative sense, and then it can redeploy it for you, which will be simpler. But as a application becomes more complicated, as we come into a routine, into a situation where you have more than one developer working on it in a normal situation, then the load becomes greater and the cost of change becomes greater too. So what we see here is that legacy is pretty much immediate. As soon as we get it into production, we have legacy of one form or another. And all future decisions will be based from this baseline, essentially. We'll have to build on top of it. And it will influence how we can roll out new features. And we don't get a chance, obviously, so we don't always get a chance to optimize for change around new features when an application is new. Usually we are in a situation where we want to create new features, roll new stuff out, and additionally, other departments of our organization or external parties, for example, may put constraints upon us where we need to add more complexity to our deployment pipeline, to our production application, which will actually slow down the pace of change. So as we grow, we find it harder to make change, essentially. So we see that legacy is immediate, but also legacy is everywhere, even in the simple-ish example that I just gave. From enterprise to scale up to startup, there are complexities which are inevitably baked into the productionizing of a service. And this happens both inside and outside of the code base through the systems that we use to support it. And inevitably then, either those systems have to be supported by an internal team or an external team. And that can create more siloing, which will then, again, slow down the pace of change that we can make. So how does this hurt us? Well, of course, we have a customer imperative. We are in a rush. We want to build stuff for customers so we get more customers. But as we've seen, it can, unless we're careful, become very difficult to implement even small changes once we have a system out there. And of course, internally, with developers, legacy systems, as they're seen, become unpopular because they're harder to work with. It creates more cognitive load, and it's therefore something that we want to avoid because we want to have an easier life, maybe. So then, sorry, just to go back to that last slide, and then perhaps we don't spend enough time on the mundane things and the systems that we have to put our application live or to keep it live or to put new features out there than we should do. Instead, perhaps we look to the future and we say, let's build something new. Let's make a microservices thing. It'll be Kubernetes. It'll be open source. It'll be a platform for the rest of the business. We can finally retire the monolith. All these kind of little mini, perhaps lies that we tell ourselves and each other to say that the next system we build will be better. And perhaps that is a way that we can look at it, but also through experience, we know that essentially we'll end up supporting one more system in addition to the legacy ones that we already have. So how can we cope with this? And I apologize that we're going quite fast here, but there's a lot of material to break into this, put into this small talk. How can we breathe life into legacy? Well, there's plenty of tactical and strategic approaches that we can take, but tactically, there are loads of things we can do with code bases. We can refactor. We can reform our organization, perhaps. Again, looking at team topologies, we can understand how better to align our code base and our application with our organization as it grows. Again, this takes investment in time, in tools, potentially, in new platforms, in thinking about how we re-architect stuff, and also in skills. So if you do actually have a legacy piece of code which is on a platform which is now not in support anymore, or dying, or too expensive to buy the license for, then you may have to rewrite it and you may have to make that call. But again, could you look at that and say, well, we can rewrite it rather than building a new application? So we can do some tactical stuff, or we can maybe switch our thinking slightly and say, if legacy is immediate, maybe engineers should always be invested in supporting business value. And how can we enable this? Well, we can accept that legacy is immediate and everywhere. And then we can empower teams to own it from the offset, from the get-go, essentially. We can potentially change our organization to be able to support this better as well. So again, thinking about team topologies, thinking about how we can have different types of team, which maybe can underpin our organization better and change our organization to better align with it. Then additionally, we can equip individuals with the skills they need to be able to cope with parts outside of their initial comfort zone. So maybe if they're very good at coding, but maybe not so good on the DevOps or CI/CD pipeline side, we can encourage that to be a part of the way that they see their job, not necessarily repurposing them to do something different, but saying, well, from a business context, this is what we want to achieve. A lot of this is really coming up with a strategy for your product in line with your business, and then pulling engineering closer to that view. On the previous slide, I did mention, sorry, going back a bit, a couple of books which are interesting. Again, I've mentioned Team Topologies a few times. It's really good. I've just finished reading that, and I will read it again straight away. Secondly, I'm reading the Unicorn Project currently, which is if you've deployed anything into production, you should definitely recognize a lot of the tropes that are on view there. It's a novel, but it's very interesting, and also aligns with this idea that the team needs to be brought closer to the business. It's not a new concept, but it's great to finally understand that there are some frameworks and some ideas that are in place in the kind of the wider context, which are finally saying, yes, this is potentially where we can go forward. So I think that was it. Kind of collapsing in a heap at the end. But yeah, the things that we can say here are, just to sum up slightly, is strategy. I think that's the last point I left it on. Important to think about how our application strategy can feed into our engineering strategy and then draw basically our business together around that. I'm going to keep challenging myself around this because this is still a work in progress, as you can tell. But I want to say thank you for your time today. And if you have any further questions, please feel to reach out to me. I'm on LinkedIn and Twitter, and I have my website linked here too. Thank you.